time. Okay, so we know how it's calculated. So when we see the formula, we're not going to say, oh, I don't know how to do this. Okay, ready? If I put this here, I'm going to touch the cable. And probably it's going to cut my camera off. But no, it didn't. Excellent. Okay, so we're going to, should I do it this way or this way? No, it's going to be out of my screen, so that's not good. Okay, so xi, I'm copying my data. Here it is. Here's my xi. 100, 102, 103, 101, 105, 100, 99, 105. Now I enter y. $257, $264, $274, $266, $277, $263, $258, and $275. At this point, I have to determine x bar and y bar. So let's go back to StatCrunch. Are we okay so far? Only Emma gives me, no, I'm kidding. Others do too. Okay, one more time. Tyler and Lana, are you here or you're gone? 1, 2, 3. Okay, you're here. Excellent. But Tyler is not, so maybe he's coming back. Okay, so let's share. Okay, I see some chat. My camera doesn't work. Okay, I'm sorry. Okay, I'm sharing the screen. So we're going to go back to what we did a long time ago with the summary stats. And we want columns. So I want the club head. I want the mean. And I want the standard deviation. Where's my keyboard? That's all I care for now. Let me see if it allows me to do both. Aha! It allows me to do both at the same time. Excellent. Good. So I want to compute. Okay, so here's the mean and standard deviation for both. I'm going to copy them. Remember, for the mean, we want 2, let's take 3 for now, decimal digits. And for the standard deviation, we want 4. So I'm copying, oh, sorry, I'm going to stop sharing. I stopped sharing, but I can see my data now, my numbers. Okay. So I have 101, 101.875, and the mean 266.75. The standard deviation for S sub x, 4 decimal digits, 2.2952, and SY, 7.7414. Say it again. Can you move your paper up a little? Like you're like in the bottom. No, the other one. Yeah. Okay, sorry. Okay. Good.
I thought we were only going 2 decimal places for the mean.
That's true. Because we're given, yeah, so you can round it up to 88. That's true. Okay. So now the next step is to determine the z-scores. So z for x, z for y, and then multiply them. accordingly. Z for x times Z for y. Ready? So let me refresh your memory what Z was, how we calculate Z. So this is xi minus x bar over sx. So this is Z for x. And of course, Z for y will be yi minus x minus y bar, of course, divided by sy. So let's do that. So 100 minus x bar over sx. So here's one way. Of course, I should be doing this with the let's do that with the lists. So instead of doing it by hand for each and every one of them. So do we have the data set? Do we have xi and yi in the graphing calculator? If we do, what I'm going to do is create a list that does this for me. It takes all the entries from xi, subtracts this number, and divides by this number. All of them at once. My data set is in list L10. So I will go to second in list, select list L10. Not before, forgive me, we have to put a parenthesis. So please insert a left parenthesis. So what you should enter should look like this. Your list, I don't know what list you have for X, subtract 101.875, close the parenthesis, and divide by 2.2952. And you get all those entries at once. Don't forget the parenthesis. It does not. Oh, it's asking me for a name first. Okay, sorry. So I'm going to call it B. Okay, because I'm so far out okay. So left parenthesis, your list, whatever your list is, subtract 101.875, close the parenthesis, and divide by 2.2952. And it gives me all the numbers right away. So negative 0.817, 0.0545, 0.4902, negative 0.381, 1.3615, negative 0.817, negative 1.253, and finally 1.3615. These are the z-scores. Now z-scores for y. I have everything in, I'm going to delete that list. Okay, so I have everything in L11 for myself. Left parenthesis, call the list, whatever list you're using. Subtract this time the mean, which is 266.75. Close the parenthesis and divide by 7.7414. So divide 7.7414 and press enter. Okay, you should allow me to do this. You allowed me before. Maybe I messed up something. Maybe I didn't have highlighted you have to have highlighted the top of the list. Maybe I didn't have that. Minus 101.875 and divide by, no, sorry, I'm rushing now. So 266.75, close the parenthesis, and divide by 7.7414. Should give us everything. So this is negative 1.259, negative 0.355, 0.9365, negative 0.097, 1.324, negative 0.48, I'm just checking, make sure that I copy correctly. Yes, 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 yes. 484. Negative 1.13 and 1.0657. What I would like to do now is multiply these two. So I'm going to multiply in another column. I'm going to multiply A by B. Okay, I'm going to call this column C. And I want to multiply A by B. So list A multiplied by list B. And just give me all the numbers. Got it. 1.0289, negative 0.019, 0.459, 0.0369, 1.8027, 0.3957, 1.4158, and the last one 1.451. Now I want the sum from I equals 1 through 8, because there are 8, of this zx multiplied by zy. I want the whole sum. And what I'm going to do, since my data is in that list, get out of there, go to stats, and now we want to calculate. And I want to calculate one variable statistics, but this is on list, the last list, which in my case is list C. And I want to calculate. Okay, give me the sum. Here is the sum. 6.57077. 6.57078. So what have we accomplished so far? All this. All this piece is done. All I have to do is divide by 8 minus 1. So finally, I'm going to write it out here because I have room. R equals this divided by 7, because we have 8 entries. 6.570778, and that will be our R. 6.570778, and I divide that by 7. 0.93868. This is the correlation coefficient, so R equals 0.93868 correlation coefficient for our data set. What would you say? Would you say it's a strong linear relationship? Would you say it's positive? Would you say it's negative? What would you say based on the correlation coefficient about the data set? What would you say?
You could say it's pretty strong.
It's pretty strong, right? It's very close to 1. And it's positive. Okay. I'm going to share my screen. Where are you guys? I'm going to share my screen again because we are going to determine all this right this moment. Okay. So I don't need all this anymore. Not yet. I need something else now. So we're going to select from here what is called regression. I didn't explain the word regression yet. I will. For simple linear. Simple linear. So stat, regression, simple linear. Click on that, please. Select the X variable. Yes, it's the club head. That's the explanatory. The response variable is the distance of the ball in yards. Just make sure that you have a fitted line plot in here as well. Maybe I shouldn't select it for the moment. I just want to show you without it. Maybe let me not select it yet. So okay, well, since we already we already had this, the scatter plot. We can. Okay. Because I haven't explained what's going to happen. So that's why I'm debating with myself. But let's say, so the X, I will explain in a minute. So the X label, I'm going to say again, club head. And I'm going to say in miles per hour. And I'm going to consider that distance. And it's going to be in yards. The more details, the better. And just make sure that you have the fitted line plot, and I'll explain what happens. We sort of talked about it, but not fully. Okay, so click on compute, please. And let's see what we have. Before you look at this table, let's click on this. And here's what it's happening here. I have the distance on the y-axis, the response variable. I have the club head, which is the explanatory variable, which is the club head in miles per hour. We already had the scatter plot. We looked at it before. And what is this? Is the line that I was showing you when we talked about linear relationship. Okay, so they already presented this because we selected it. We selected the line of best fit. And now I'll come back to it and explain what it is on paper. Now let's go back to see what this is all about. So dependent variable, which is the response, is the distance. The independent on the x-axis. I'll come back to this in a minute. We have a sample size of 8. And look at our correlation coefficient. Of course, they did more work, okay, and they got a better approximation than we did. We got 0.93868, and they got 0.3869. So obviously, we have a little error somewhere. This is a better approximation, of course. I think that that's all I wanted to show here before I explain. So I'm going to have to stop sharing to explain what is happening and how we determine that line that you saw. So this line, what is this all about and how do we get it? Okay, so let me stop sharing and explain that. And then we'll come back to